This is better, though, than this. So if we have a dissolved mixture of magnesium nitrate and magnesium chloride in this reaction, the mixture, dissolving the mixture in water, 0.5 molarity of silver nitrate is added drop-wise, which just means drop by drop, until precipitate formation is complete. It says that a precipitate is formed. What precipitate is it? Take a look at the mixture of ions in there, and there's one thing that should precipitate. Yes, ma'am? Silver ions that have just been added to the chloride ions in that mixture that were in there. Would everybody agree that silver chloride is our precipitate?
Yes.
Go ahead. Chloride and the other halogen negative ions is almost always soluble, except in, there's three things. Silver is one of them.
Lead, magnesium.
Lead, somebody said magnesium, no.
Or then, I was thinking.
Yeah, silver, lead, and yes. Mercury 1. There are two mercuries, there's 1 and 2. Is the mercury 1 ion that is not soluble with chloride. All right. So that's our precipitate that we have here. It says the mass of the precipitate, that was the silver chloride, is given to. It's 0.641 grams. And so what was the mass percent of magnesium chloride back in the original mixture? Does that look kind of familiar, like we've done a lab similar to that? We had a mixture of things that were dissolved and a precipitate was formed, and it was collected. You're not even responding to that. We're kind of lunched out today. Get too much starch at lunch, is that what it is? Or you like that when I pass back reading quizzes, you're like, oh, screw this. Right? Oh, gosh. Don't be like that. Just get your reading quiz back and be, okay, I'm going to do better today. If I were, and again, please, don't write this down because I'm going to breeze through this way too fast for us to spend any time on it. But the chloride at the beginning came from magnesium chloride. So if I put MgCl2 up here, that's magnesium chloride, that's aqueous, plus silver nitrate, that is the combination of things that's going to make the precipitate. And so we're going to get the silver chloride, AgCl, and then the magnesium and the nitrate. Balancing this equation, it looks like that. The 0.641 is the mass of the precipitate, that's the silver chloride. So the problem didn't give you any of this information, but we know enough now that we can come up with this chemical equation. We can come up with the mass of the precipitate. Well, that was given to us, but it didn't say what it was. From solubility, though, we know that that's the precipitate. And the question is, what is the mass percent of magnesium chloride? So if we can find how many grams of magnesium chloride reacted, can we answer the question? Yeah, that's what we have to do. Yeah.
Does magnesium nitrate not go in because it doesn't do anything?
That's right. The magnesium ions are just spectators. The nitrate ions are just spectators. In fact, more nitrate ions were added from the silver, but it doesn't matter because they're not doing anything. Yep. So you can just use the fact that, now it did say until formation is complete. That means that we ran out of all the chloride ions. They keep adding silver until all the chlorides have been precipitated. Then you know that that was our limiting reagent. And so the amount of that you get is dictated by that. Yes, sir?
So the only reason the magnesium nitrate is spectated is because neither magnesium nor nitrate are soluble. Both of them are soluble in water.
Right. I was going to say neither are insoluble, but yeah, both of them are soluble. Yeah, that's right. Okay. So, I need to tell you, and I've mentioned before that I try to come up with memory tricks to help me remember stuff. If I've got something that I have to memorize, I don't like that. I don't like memorizing information. Now, I used to be in the school plays when I was in high school. Can you see me as an actor? Actress, right? Nice.
Yeah.
Oh, yeah. I was an actress in high school. How's that? But I love memorizing lines. I thought that was fun because, you know, the lines all go together. And, you know, you practice it a few times, and by the end, I've got everybody's lines memorized because we just go through it so many times. Anybody in here in TTE? Are you,
Middle
Julianne?
school.
Yeah. In middle school you were? Did you like memorizing lines? Julianne?
I knew everybody.
Yeah? I do too. I always did enjoy that. But memorizing facts like this, there's 3 ions that are insoluble with chloride. What are these? I don't know. So I come up with a memory trick. Now, I'm going to share my memory trick with you, but it's probably not going to mean anything to you. When I was a kid, my mom and dad had a cottage up north. And I lived around here. Not in Troy, but over in Utica. And we would go up north on the weekends, and they had a boat up there, and we would water ski and tube, and fish and that kind of thing. I was around boats my whole life. Had a friend that had a boat on Lake St. Clair. We'd go out there and have fun, fish. So when I had to memorize the things that were insoluble with chloride, I got silver, lead, mercury. Is there some way that those are all connected? And so I came up with this. If you're a boat person, you may have seen these things before. A Mercury outboard motor. You ever seen motors, boat motors? Yeah. Mercury is a big brand of outboard. And this kind of motor is an outboard motor. Put that on the back of the boat and it pushes the boat around. I saw a lot of these when I was a kid. My friends had Mercury motors on their boats. And so this is what helps me to remember the things that are insoluble with chloride. I look at this and I see the word mercury on the side of the motor. What else is there? A silver-colored stripe. And not only that, but these old motors, and this is probably out of the 50s. That's an old motor. This is more of a 70s Mercury motor. So I mean, these are that's way older than I was. I was born in 71, so this is something that I would have seen as a kid. Back in those days, we bought leaded gasoline. When you go to the gas station and you buy, it says unleaded and it gives the price. You ever wonder why it says unleaded? Your generation, you never have to worry about it. But when I was a kid, the gasoline had lead in it. And it was just in like around 1980 that they stopped putting lead in gasoline. Lead was in gasoline to, it helps the combustion process in a motor. And so they realized, gosh, we're putting a whole lot of lead into the air, into the environment, into water. Maybe we shouldn't do that. So they came up with a different formulation for gasoline that had no lead in it. So now we use unleaded gasoline. But we have, here's an old gas pump, and it has all this. It says, for use as a motor fuel only, contains lead. This would be a leaded gasoline pump. So when I'm trying to remember what is insoluble with chlorides and bromides and iodide, I think of the mercury motor because you got mercury, silver, and lead. And now the lead, because these motors used to run on leaded gasoline, I just mentioned that to just remind you, if you can come up with memory tricks to help you to remember things, the more zany they are, the better. And the more they relate to you, the better too. And, I've got Marette Habib in one of my hours. You know Marette? She's a sweetheart. And she sits right there. And she's like, yeah, that motor doesn't work for me. Because maybe she's not a boat person. She said, she looked at these and said, Amanda hates peanut butter. I thought, that's really good too. So, if that's something that your brain can wrap around, then use that. Or some other way to remember these.
Only Mercury 1 is...
Only Mercury 1, yeah. Yep. I just bring that up to remind you that, if you're needing to memorize things, especially almost random facts, I mean, what do silver, lead, and mercury have in common to you? Not much. They're elements. So how do you remember those three for parts? Well, see if you can put them together somehow. What do they all have in common? So there's that. Now, I'm done with precipitation. We're going to take on acid-base chemistry here for a few days. Starting tomorrow, we're going to have a lab on an acid-base neutralization reaction, so we have to start there. Yes?
Wait, when did you say only mercury 1, what does that mean? Only mercury 1 is soluble?
Is insoluble.
It's insoluble.
Yep. Chloride is soluble in everything except for mercury 1, lead, and silver.
What are the other forms of mercury?
Mercury 2. There's Hg with a positive 2. Mercury 1 is Hg2 with a positive 2, which means each Hg is positive 1. It's ridiculous.
Killing me here.
I know. It's not fun for me either. I wish I could just write Hg positive 1 like everything else. But we can't. So there's two definitions of acids and bases that we're going to have to familiarize ourselves with. There's Arrhenius acid and bases by this Norwegian guy, Svante Arrhenius. He was the first person to come up with a theory about what acids and bases were and find them like this. This is a very good definition that lends itself well to when you mix acids and bases together. Because acids always have hydrogen to start with, bases always end with hydroxide, so you just have a double replacement to contend with. Yes?
If something is weak electrolyte, it won't dissociate completely. So what if you have like an acid that dissociates completely but a base that doesn't? So how do you know how much help you have?
That would be a strong acid with a weak base, right?
So
Acids and bases really like one another. They, the hydrogen ion and the hydroxide ion, they're very attracted to one another to make water. So even if you have a weak base, if you have free hydrogen ions around, they're going to find each other, and the hydrogen is going to rip the hydroxide off of the base. It will.
What if they're both
What if they're both what?
weak?
We're not going to deal with that too much. You're never going to have a weak acid and a weak base reacting and have you need to know what to do with it. We're not going there. Okay? Going to keep it simple. Simpler. It could be worse. I'll say that. It could be worse, Jennifer. Can I say that?
No.
A truth?
precipitates tend to pull things off of each other, but water really good, so why would it pull it off?
Water's what?
Water's going to be water, right? So why would it tend to pull it off instead of letting it be?
Because there's such a strong attraction for hydrogen ions and hydroxide ions. And it goes back to the sense of equilibrium. We're going to learn a lot more about the detail of why it is that acids and bases are so attracted, why the hydrogen and hydroxide ion like each other so much. It has to do with the equilibrium constant value for those. And the fact that water is very stable as an H2O molecule and not dissociated as hydrogen and hydroxide. These are double replacement reactions. If you remember double replacement, you have a positive and negative. The positive in an acid is the hydrogen ion, and then the negative is some anion. Then in the base, as long as it's an Arrhenius definition of a base, you're going to have some metal and hydroxide. The hydrogen ion and the metal will rearrange and switch places. The hydrogen goes over here with the hydroxide. That's where we get the water, hydrogen and hydroxide. The cation here joins up with the anion here, and that makes some ionic compound that we know as a salt. All right, let's take a look at the strong and strong acids and the strong bases. You probably have seen these before. Yes? The 6 strong acid, Rahi? Yeah, so you need to know those. Yep. I think it's way more important, 10 times more important to memorize the acids than the bases. You should know these two. Now, here in this lecture, I'm going to give you a couple of these, and you'd have to know that they're strong bases. But sodium hydroxide, potassium hydroxide, by far, those are the, by way far, most common strong bases, sodium and potassium hydroxide. Yeah?
Wouldn't HF be over there? Because it's pretty strong acid.
Wouldn't what?
HF
HF?
and fluorine.
No. There's other acids that are stronger than HF. Other weak acids that are strong. I mean, HF is kind of down there on the strength of acid scale. The reason is because, you know, you have a hydrogen with a halogen, halogen, halogen. What about fluorine? Why isn't HF as up there? Fluorine tends to hang on to hydrogen more than we expect it to. It has, I think, to do mostly with fluorine's size. It's a real small atom, small ion too. And I think hydrogen can tuck itself up there with the fluorine better than it can with these things. With these are big ions, and the hydrogen doesn't tend to be able to hang on as well because these are big atoms, so it doesn't really have a place on those things. It gets kicked off easily. Fluorine, it's a little